Edexcel, GCSE, Mathematics Linear, Paper 4, Calculator, Higher Tier, June 2009. On the formula page, write down anything you think you're going to struggle to remember during the exam. For example, you might want to remind yourself of the trigonometric relationships, or you might want to remind yourself to find the sum of the angles in a polygon. You take the number of sides, subtract 2, and then multiply by 180. Anything you think you might struggle to remember if you're concentrating during the rest of the exam. On question 1, we're asked to change £325 into euros, and we're given an exchange rate of £1 is €1.68. So as this is a calculator exam, I'm able to use my calculator to take the original relationship and try and turn that £1 into £325. And for that to happen, I'm obviously going to multiply this by 325. So I need to take this side and multiply that by 325 as well. So on the calculator, 1.68 times by 325 equals €546. So my answer is €546. In part B, I'm told that when she came home, she changed her €117 back into pounds, and I'm given a different exchange rate. So my exchange rate is now £1 is equal to €1.50, and I'm told that she's going to change €117 back into pounds. So what I need to know is the relationship between these two values. So I need to find out how I go from here to here. So 117 divided by 1.50, or just 1.5, tells me that that's a division by 78. So to go from there to there, I'm dividing by 78, and therefore to come from £1, I need to multiply by 78. And 1 times by 78 would be £78. On question 2, I'm asked to draw an enlargement of the shape, scale factor 2. I'm not given a centre of enlargement, so it can be anywhere on the grid. So the original shape is down here, just highlight that so you can see it. And this side here is 3, and this side here is 3. So when I'm doing a scale factor of 2, I need to take both of those lengths and double them. So I need it to be 6 squares along horizontally and 6 squares vertically. So I'm going to start here and I'm going to count 1, 2, 3, 4, 5, 6 squares up. And similarly 1, 2, 3, 4, 5, 6 squares across. Now all of these distances are 1. So if they're going to get times by 2, they're now all going to be 2. So from here to here should now be 2. And similarly for the rest of the shape, all of those are now 2 squares. And then to finish it off, I just need to connect those points. Now obviously in your exam, you would do this with a ruler, but just quickly, that's what the shape could look like. It can be anywhere on this grid, it doesn't have to start here, it could have started down here, as long as it fits on. In question 2b, I'm told to describe fully the single transformation. So it's important that I realise a transformation is one of 4. So the first one it could be is an enlargement. The second one it could be is a reflection. We've got a rotation is my other transformation. And finally the fourth one is a translation. Now of those 4, I can see that going from A to B is a reflection. So that's the first word I need to write down as part of my answer, and I'll get a mark for that, is to write down reflection, and then I need to give the line that it's reflected. Well, I can see that it is reflected in this line here, so I can either write down that it's a reflection in the y-axis, or I could write down that that's a reflection in the line x equals 0, because any points on this line will have x coordinates of 0. On question 3, I'm asked to write down the first 3 terms of a number sequence that is given by n squared plus 1. So for the first term, n would have to be 1, in which case n squared plus 1 would be 1 squared plus 1, which would be 1 plus 1, which is 2. For n equals 2, again n squared plus 1 will be 2 squared plus 1, which is 4 plus 1, which is 5. Similarly, for n equals 3, n squared plus 1 equals 3 squared plus 1, which is 9 plus 1, which will be 10. So the first three terms of the sequence are 2, 5, and 10. It's important you don't do what I nearly did, which is say that 1 squared is 2. 1 squared is actually still 1. On number 4, I'm given a scatter diagram showing some information about 8 sheep with the height going horizontally and the length going vertically. I'm then asked to plot the information for 2 more sheep on the graph. So the first one is a height of 65, so a height of 65 and a length of 100. So I'm going to come up 65 until I come to 100, put a cross on. The second one is a height of 80 and a length of 110. So a height of 80 and I'm going to come up to 110, and that's my second point there. And I can tell that they're roughly right as they fit the general pattern of these points. On part B, I'm asked to describe the relationship between the height and length of these sheep. So as I'm asked to describe the relationship, I can see that as the sheep get taller, they also get longer. And I'm just going to summarize that here. Now you would get away with here writing positive correlation. However, when it wants correlation, it usually asks for correlation. Here it's asked for the relationship. So it's worthwhile covering yourself and writing both if you're not sure. In part C, I'm told that the height of a sheep is 76 centimeters, and I'm asked to estimate the length of this sheep. So this part of the question requires you to put a line of best fit on the scatter diagram. So the line of best fit should go roughly through the middle, which looks not too far away from there. And it should go all the way across your graph, so that's the line of best fit. Once we've done that, I need to take the value I'm given, which is a height of 76, which would be here. And again, make sure you check your scale. Is it going up in ones? 75, 76, 77, 78, 79, 80. It is going up in ones, so that's the right place. And I need to draw a line up from there to my graph, and then a line across from there back to my scale on the vertical axis. Now I can see from there that this is in between 100 and 110, and I've got to check the scale, and from this I can see that it's going up in 2s, so that would be 108. So the length of this sheep would be 108, and I've already got the units centimeters. On question 5, I'm told that Julie buys 19 identical calculators and that the total cost is £143.64. So I know that 19 cost 143.64. So to work out what 1 costs, I'm going to do 143.64 divided by 19. On the calculator, that would be 143.64 divided by 19. And that is 7.56. And it doesn't matter that I've not put the pounds in at this stage. So 1 costs £7.56, and I have to work out the cost of 31. So 31 times by 7.56, and again on my calculator, 31 times 7.56 is 234.36. Now I'm going to write that answer down here. It's already put the pound sign on for me. It's worthwhile checking that I have, because it's pounds and pence. I've got 2 numbers here after the decimal point. On question 6, I'm given the formula to convert Fahrenheit to Celsius, which is F equals 1.8C plus 32, and I'm asked to work out the value of F when C equals negative 8. So I'm going to work out F when C is negative 8. So that needs to be 1.8 lots of negative 8, and I want to add 32. So I'm going to do 1.8 times negative 8 and add 32. Now on the calculator, 1.8 times by negative 8. And I need to add on to that 32. and that's going to tell me that the answer is 17.6. It's important here that I use the negative button down the bottom, not the minus here. Part B, I'm told to work out the value of C when f equals 68. So again, I've got f is 68, so I'm going to substitute that in for f. And the rest of my formula is 1.8c plus 32. So I need to solve this equation. So I'm going to take 32 off both sides to get rid of this. And that's going to leave me with 36 on this side and 1.8c on this side. Well, this is 1.8 times by c, so I'm going to divide it by 1.8. And that will tell me what c is. So 36 divided by 1.8 is 20. So c equals 20. On question 7, I'm shown the position of two boats, P and Q, and I'm told that the bearing of boat R from boat P is 60 degrees. So from P means I'm starting at point P and I need to measure a bearing of 60 degrees. So making sure I put my protractor in the right starting place with the crosshairs on the X, I'm going to measure around 60 degrees, which is there. And therefore I can now draw on bearing through that point to tell me where R would be. So R is somewhere on this blue line. I'm then told that the bearing of boat R from boat Q, so starting at boat Q, is 310 degrees. So I need to measure a bearing of 310 degrees from Q. Now if I put my protractor on point Q, I can see that I won't be able to get all the way around to 310. So what I'm going to do is draw a line down from Q, and I know that this side will be 180. And therefore if I'm going to measure 310 in total, if I do 310 take away 180, I get 130. And that means I need to add on a further 130 degrees round here. So again, place my protractor on the mark at Q, making sure I line that up, and I'm going to count down from 0 to 130. So 0, 10, 20 and so on till I get round here to 130. And that now represents the bearing of the boat R from Q. And I can draw that bearing on, and where these two lines cross, that's where the boat R would be. On question 8, I'm told there's some sweets in a bag and that 18 of them are toffees and 12 of them are mints. So I've got toffees, and there's 18 of them, and then I've got mints, and there are 12 of them. And in the first part, I'm asked to write it in its simplest form, so I need to make these numbers smaller. Now they're both in the 6 times table, so I can divide them both by 6, and I get 3 here and 2 there. So a simplified ratio is 3 and 2. I'm then told there are some oranges and apples in a box, and the total number of oranges and apples is 54. So I've got oranges, I've got apples, and then I've got a total. And I know that there is 54 in total. I'm told that the ratio of the number of oranges to apples, so oranges to apples, is 1 to 5. So if I had one set, I would have 6 in total. And I'm asked to work out the number of apples in the box. Well, I can see that to go from here to here is multiplying by 9. If you're not sure, that's 54 divided by 6 equals 9. And therefore for both of these numbers, I also need to multiply by 9. So 1 times by 9 will be 9, and 5 times by 9 will be 45. And that should add up to the 54 I've got here, and it does. So the only thing left is to make sure I've answered the question, which is how many apples. So 45 apples. On question 9, I'm given an equation, x cubed plus 20x equals 71, and I'm told there's a solution between 2 and 3. And I'm asked to work out my answer to one decimal place, showing all of my working. So I'm going to have a table where I've got my x values on the left hand side. And the first one I'm going to try is 2, and the next one is 3. And then I'm going to work out what x cubed plus 20x is, and I'm going to compare that to 71. And then I'm going to make a comment here. Okay, So I'm going to start with 2, and on my calculator I need to do 2 cubed plus 20 lots of 2. So I'm going to put 20 times 2, and that will give me 48. So in the first one I did 2 cubed plus 20 lots of 2, and that gave me 48. And that obviously is too small. So now I'm going to try 3. So 3 cubed plus 20 lots of 3 would be 87. And again, 3 cubed plus 20 lots of 3 will be 87, and that's too large. So I now know that my answer is somewhere in between 2 and 3, and looking at these, it looks like it will be a little bit closer to 3 than 2. So I'm going to try 2.6. So 2.6, and I'm going to do 2.6 cubed plus 20 lots of 2.6. So 2.6 cubed plus 20 lots of 2.6. And notice here I've used the brackets. I can do that, or I can use the multiply. And I get 69.576, which is just too small. So now I'm going to try 2.7. Same again, 2.7 cubed plus 20 lots of 2.7. Again, using the brackets if I want to, and that's 73.6. It does ask me to show all my working, so I'm going to write that down. So that is too large. So I know that so far my answer was in between 2 and 3. I've then narrowed it down to in between 2.6 and 2.7. So my answer is going to be one of these two. So either x is 2.6 or x is 2.7. And what we've got to do now is figure out which one it's closer to. And to do that, I'm going to go in the middle of the two of them at 2.65. So I'm going to try 2.65. So I'm going to do 2.65 cubed plus 20 lots of 2.65. And again on my calculator, 2.65 cubed plus 20 lots of 2.65 is 71.609625, and that is too large. So my answer must be, because this is too large, somewhere in this region here, and because it's in that region there, it means it's closer to this value here. So my answer is x equals 2.6. Notice I only had to try one number that had more than one decimal place. On question 10, I'm asked to construct the bisector of this angle showing all my construction lines. So I'm not allowed to measure it with a protractor because I'm asked to show my construction lines. So that means I'm going to need to use a pair of compasses. To do that, I'm going to take my compasses and I'm going to place them on the point of the angle, and I'm going to draw an arc that crosses here and here. And then I'm going to take my compass and repeat that without changing it and draw another arc there and here. We should see that they cross at this point here. Now I can take my ruler and draw a line from there to there. That has bisected that arc. And if you're not sure in your exam whether you've got it right, you can always measure both of those angles. This angle here is approximately 25 degrees there or thereabouts, maybe 24. That's 24 degrees there, and that should mean that this will be 24 degrees as well. So if I measure that, I've got just over 24, so a little bit out. I've got about 25 there. So you get a little bit of leeway, but it's worth checking that you've got it. On question 11, I'm told that Therese says that the sum of two prime numbers is always an even number. And I'm told that he is wrong, and I'm asked to explain why. And they have put wrong in bold type here, so I know that he's definitely wrong. So we shouldn't be writing anything down about that he's right. So prime numbers, I know the first prime number is 2, and then it's 3, 5, 7, and then 11, because each of these can only be made one way. So 2 can only be done as 1 times 2, 3 can only be done as 1 times 3, and therefore they've got exactly 2 factors. Notice that 1 isn't a prime number because it has only one factor, which is obviously the number 1. So the sum of two prime numbers, and sum means add, is always an even number. Well, this is wrong, and I can show that it's wrong because if I use these first two prime numbers and do 2 add 3, I get 5. And therefore I can either show this or I can write a statement down here reflecting this, saying something along the lines of 2 is a prime number. So added to any of the other prime numbers that are odd, that will give me an odd number. Any statement along those lines will do, as long as you've shown an example that doesn't work and then highlighted that we are doing an even number added to an odd number, and therefore we're always going to get an odd number if we use the prime number 2. On question 12, I'm given the time taken in minutes to repair 80 car tyres, and I can see that information has been grouped. So the time for the first group is between 0 and 6 minutes, and that 15 cars took that long to have their tyres repaired. I'm asked to calculate an estimate for the mean, and the key word there is estimate, because I don't actually know how long each of the times was, I just know what group they were in. So to do that, I'm going to need to work out a midpoint for each of these groups here. So the midpoint for the first one is 3, and that's because I'm going to take 0, add it to 6, and then divide it by 2 and get 3. And that gives me an estimate of the time taken for each of these 15 cars. Now I can repeat that process for each of these groups, so 6 and 12. The midpoint there is going to be 9, 12 and 18 it's going to be 15, for 18 and 24 it's going to be 21, and for 24 and 30 it's going to be 27. What I now need to do is work out, assuming that each of these repairs took 3 minutes and there were 15 repairs, what the total time was. So the total time for that first set is going to be 15, as there were 15 lots of repairs, and each one we've estimated took 3 minutes, so 15 times 3 is 45. So this one here is going to be 45. And I'm therefore going to repeat that process, multiplying these numbers together. So 25 times by 9, 20 times by 15, 12 times by 21, and 8 times by 27. Now you're allowed to use a calculator to do all of these, so it's worthwhile doing it rather than trying to do it in your head. 20 times by 9 is 225. 20 times by 15 is going to be 300. 12 times by 21 is going to be 252. And 8 times by 27 is going to be 216. You don't get extra marks for doing it in your head, so it is worth just checking them on your calculator. Once I've written all of those in there, the table is complete. Notice that on some exams they don't give you this table, you'd have to add the extra columns on yourself. Now this is called the midpoint time by frequency. Okay, so an estimate for the mean. So I want the mean estimate is the total time taken divided by how many there are. So the total time taken is from this column here. So I'm going to add those up. So I'm going to do 45, add 225, add 300, add 252, add 216. And I'm going to get 1038 for this column. And how many there are is given by the total of the frequency column, so I'm going to add them up. 15, add 25, add 20, add 12, add 8, which is 80. And in reality I didn't need to do that, as I was told there was 80 up here. So my estimate for the mean is going to be those two numbers divided. And 1038 divided by 80 is 12.975. And I'm not asked to round that, so I can just copy that straight across, and they've given me the units. On question 13, I'm given a semicircle, and I'm told the diameter is 8, and I'm asked to work out the perimeter of the tile. So the perimeter is going to involve this distance around here, but it's also going to involve this distance across here. Well, I already know the diameter, so I just need to know the arc length here. Now I know that the circumference of a circle is pi times by the diameter. So in this case, the circumference is going to be pi times by 8. That would give me the circumference of the whole circle. I only want half of it, so if I'm going to work out the arc, I'm going to have to do the circumference divided by 2. So I'm going to take pi times 8, or 8 pi, then I'm going to divide it by 2, which is going to give me 4 pi. That's the arc length. Then got to add on the diameter, so the perimeter is going to be the arc plus the diameter. The arc is 4 pi and the diameter is 8. So if I work that out, again on my calculator, 4 pi plus 8, I get 20.56637.061. Now, despite the fact that it asked me to round my answer, it's worth writing out the full answer so that if you get the rounding wrong, you don't lose that mark. So 2 decimal places, well, there's the second decimal place. So I'm going to look at the 6 after it, and that's going to add 1 on. And therefore my answer is going to be to 2 decimal places, 20.57. On question 14, part A, I'm asked to simplify A times A times A, which is A cubed. Part B, I'm asked to expand 5 lots of 3x minus 2, so I'm going to draw a diagram. 5 lots of 3x minus 2. 5 lots of 3x would be 15x. 5 lots of minus 2 would be minus 10. So 15x minus 10. Similarly, in part C, I'm asked to expand another bracket. So I've got 3y and y add 4. So y times y is y squared. So 3y times y would be 3y squared. 3 times 4 is 12. And therefore 3y times 4 would be 12y. And it's being added on. So 3y squared plus 12y. In part D, I'm asked to expand 2 linear brackets and then combine them by adding. So 2 lots of x minus 4. And I want to add on to that. So add 3 lots of x plus 2. So that would be 2x minus 8. This would be 3 times x is 3x. But here I'm going to have add 3x. 3 times 2 is 6. And positive times a positive is a positive. So altogether I've got 2x minus 8 plus 3x plus 6. All I've got to do now is combine like terms. So I've got 2x, add 3x, which would be 5x. And I'm going to take away 8 and then add 6, which would be the same as taking away 2 altogether. In part E, I'm asked to expand 2 brackets. So I'm going to use this diagram to help me. I've got x add 4 and x take away 3. X times by x would be x squared. X times by 3 would be 3x. Therefore, that would be take away 3x. X times by 4 again would be 4x. I'm adding 4x here because I've got an add here. And then this is the one we've got to be careful with. 3 times by 4 is 12. And add times by take away is going to be take away 12. So I've got x squared minus 3x plus 4x minus 12. And again, I can combine these two terms always in this diagram. So I've got take away 3x, add 4x, which would be the same as just adding 1x. Take away 12. Now when I write the answer, I'm going to take that 1 out and just write add x, take away 12. And it's worthwhile doing that. On question 15, I'm given sum here, and I'm asked to work it out and write down all the numbers on my calculator display. A couple of ways of doing this. Most straightforward, that will involve probably the fewest mistakes, is to work out the top and bottom of the fractions separately. So 4.6 add 3.85, 4.6 add 3.85 is 8.45, and that's the numerator of my fraction, and then I'm going to work out 3.2 squared take away 6.51. So 3.2 squared take away 6.51, and that's 3.73. And now all I'm doing is I'm doing the division implied by that fraction. So 8.45 divided by 3.73. So 8.45 divided by 3.73 equals 2.2654155. And that's my answer. I'm not asked to round it. Now, you can do this in one step if you remember to put brackets around the top and the bottom of the fraction. So opening the top bracket, 4.6 plus 3.85, and close that bracket, tells it to do that bit first, and then divide it by the answer to the second part. If I open another bracket, 3.2 squared, take away 6.51, and close that bracket. And I get the same answer of 2.2654155. 555. Either way is fine. I would encourage you to do it this way as you're likely to make fewer mistakes. On question 16, I must simplify T6 times T2, and these are both powers, the 6 and the 2. So that's T times T times T, and so on, 4, 5, 6, and I'm multiplying that by T times T. So I can see that I've got 8 altogether, so my answer would just be T8. Similarly in part B, I've got M8, which will take me a while to do, but 8 lots of M, 3, 4, 5, 6, 7, 8, and I'm dividing that by, it's a fraction, m to the power of 3. So if I write it out like that, I can see that I can cancel the top and the bottom of this fraction by m 3 times until I'm left with m times m times m times m times m, or just m to the power of 5. And I can do that more straightforward by doing 8 take away 3, and that will get me the 5. In part C, I'm going to do 2x cubed, so I'm going to do 2x times 2x times 2x. So 2 times 2 times 2 would be 8. X times x times x would be x cubed. And in part D, I'm going to do 3a squared, so I'm going to write the 3, and then I'm going to multiply that by the 4. And then I'm going to have the a squared multiplied by the a to the power of 5, and then I've got h times h to the power of 4. And if I do each piece separately, I can put them together at the end. So 3 times 4 is 12. A squared times a to the power of 5 is a to the power of 7. I can just add those powers. And h times h to the power of 4 is h5. The reason being for that is that h is h to the power of 1. So my answer will be 12 a to the power of 7 h to the power of 5. In question 17, I'm asked to work out the length AB in a right angled triangle, and I'm given two other lengths, AC of 6 and BC of 9. So this is going to be a Pythagoras question, so I'm going to label the sides. I'm going to call this one L for the longest sides. Some people call it H for the hypotenuse, or C, depending on how you've been taught this. I'm going to call this side the shortest side, and this side the medium side. Again, some people will call this one A, some people will call this one B. Okay, so using my version, I've got the short one squared plus the medium one squared equals the long one squared. So the short one is 6 squared, add to the medium one, which I don't know what it is, squared, should equal the long one, which is 9 squared. Now it's important that we recognise that the longest square side in a right angled triangle is always opposite the right angle. So now it's just a case of squaring both of those numbers and then solving the resultant equation that I get. So I'm going to take away 36 from both sides, and then I'll be left with m squared on its own. So then I'm going to have m squared equals 45. And to work out what m is, I'm going to have to get rid of the squared, so I'm going to do the opposite of that, which is the square root. And therefore I'm going to have m equals the square root of 45. I can work that out on the calculator. So the square root of 45 is 6.708203932. Now I'm asked to round that to three significant figures. So the first significant figure is the 6, second one's the 7, so the third one is the 0. I'm going to look at the number after it, which is the 8, which is 5 or more, so I'm going to add 1 to the 0. So to three significant figures, that is going to be 6.71 centimeters. On question 18, I'm shown a box plot that gives you some information about the distribution of weights of bags on a plane. And there are 5 points on a box plot. The first one here is the maximum, which in this case I can see is 29. This is the minimum, which is 5. I've also got the lower quartile here, 10. I've got the upper quartile at 23. And in the middle, this line here represents the median. And the median there is equal to 17. So Jean says the heaviest bag weighs 23 kilograms. She's wrong, explain why. I can say that the maximum is 29 kilograms. Part B, write down the median weight. Well, I've already worked that out, that's 17 kilograms. Part C, I'm asked to work out the interquartile range of the weights. Well, the interquartile range, my QR, is equal to the upper quartile take away the lower quartile, the distance between these two quartiles. So I'm going to do 23, take away 10, which is 13. In part D, I'm told there are 240 bags on the plane, and I'm asked to work out the number of bags with a weight of 10 kilograms or less. So 10 kilograms is here, which is the lower quartile, and therefore there is 25% below that lower quartile, same as there's 25% above the upper quartile, and we've got 50% in the middle here. Okay, so I know that it is 25% of 240. So 25% of 240 is 240 divided by 4, which would be 60. So there are 60 bags with a weight of 10 kilograms or less. On question 19, I'm told that Toby invested 4,500 for 2 years in a savings account. So the important figures here are 4,500, 2 years, and an interest of 4% per annum, and it's compound. And I'm asked to work out how much he's got after 2 years. So I need to do 4,500. I need to times it by the interest rate and for the period of 2 years. Now the interest rate of 4% I need to turn into a multiplier. So he's always going to have 100%. He's now going to have on the 4% added on, because he's getting interest, which is 104%. And as a decimal, that would be 1.04. I've just divided that by 100. Okay, so my multiplier is 1.04, and that is for 2 years, so I'm going to do it to the power of 2. So 4,500 times 1.04 to the power of 2. 4,500 times 1.04 to the power of 2. And my answer is 4867.2. Now if I write that down as my answer, I'm going to lose a mark because I need to recognise that this is an amount in pounds and pence, so I need to add in this 0. In part B, I'm told that Jasper invested 2,400 for an unknown amount of years, n, in a savings account and was given 7.5% per annum compound interest. And I'm asked to work out that at the end of n years he had £3,445.51 to work out the value of n. So again, first of all, I'm going to take my interest rate, 7.5. I'm going to add it onto the 100%, which is 107.5%. I'm going to work out as a decimal. That would give me a multiplier of 1.075. So I'm trying to do 2,400 times 1.075 to the power of some number n, which we don't know what it is, and it's going to give me £3,445.51. And this is a question of trying that out on your calculator. Now you could solve this and divide both sides by 2,400. And if I divide both sides by 2,400, I'm going to get 1.075 to the power of n equals 1.43562967. And all I've got to do now is try a value of n until I can get this answer. And it is trial and improvement. So if I do 1.075 to the power of, and the power button on this calculator is there, and I'm going to try 7. And that was a little bit too much. So I tried n was equal to 7, and that gave me 1.65904914. So I'm going to try the number underneath that. I'm going to try n equals 6. 1.075 to the power of 6. And again, that was a little bit large, but you can see I'm working my way closer. 3301526. So now I'm going to try n equals 5. So 1.075 to the power of 5. And that gives me the number I'm after. So I can tell that n must be 5, and therefore it was 5 years. You don't have to do it that way. You could try it by just putting the numbers into this calculation and doing 2400 times 1.075 to the power of 5. And we're trying to get this number here as opposed to this number. Either way will work fine. On question 20, I'm given a right-angled triangle and asked to work out the size of the angle marked x. And I've given the sides here of 5 and 8. Now this is a trigonometry question, so I'm going to label the sides. We'll start off with the longest side, the hypotenuse, which previously is through the right angle. This in relation to this angle is the opposite. This one therefore is the adjacent. Now if I write down my trig formulas, which is Sine is the opposite over the hypotenuse, cosine is the adjacent over the hypotenuse, and tan is the opposite over the adjacent. It's then a case of seeing what I've got. So I've got the hypotenuse and I've got the adjacent, and therefore the hypotenuse and the adjacent are both in this formula. So I'm going to use the cosine of my angle x is equal to the adjacent, which is 5, over the hypotenuse, which is 8. Now I need to know x, not cosine x, so I'm going to do x equals cosine to the minus 1, 5 over 8. Now, I can work that out on my calculator. The first thing is going to make sure that my calculator is in degrees. So this one here, the DRG button, I press that until I make sure I've got degrees at the top, otherwise my answer will be wrong. I want cosine to the minus 1, so it's second function cosine. Open the brackets, 5 divided by 8, and that gets me my angle of 51.3178, and so on. So x equals 51.31781. 255. Now I'm asked to round it to one decimal place, so there's the first decimal place. Underline the 1, which is 4 or less, so the 3 stays as it is. So my answer is going to be 51.3 degrees. In part B, I'm given another triangle and I'm asked to work out the value of y. So I'm going to go through the same process. Again, this is the hypotenuse here. This would be the opposite in relation to this angle, and this is the adjacent. So if I write down the formulas again, I've got sine is opposite over the hypotenuse, cos is the adjacent over the hypotenuse, and tan is the opposite over the adjacent. So I've got the adjacent and I want to know the opposite. So the formula with both of those in, opposite and adjacent, is this one here. So I'm going to write down that tan of my angle, which is 40 degrees, I'm giving it this time, is equal to the opposite, which is y, over the adjacent, which is 12.5. Now I need to know what y is, so I'm going to have to do a little bit of rearrangement here. So I'm going to multiply by 12.5 to get rid of this divide by 12.5, and that will get me that 12.5 times my tan 40 is equal to y. So on my calculator, again, still in degrees, 12.5 times by tan 40, and that is y is equal to 10.48874539. Now, I need that to one decimal place, so again, there's the first decimal place. 8 is 5 or more, so I'm going to add 1, and therefore my answer is going to be y is equal to 10.5. And I haven't got any units here, so I'm going to make sure that I write in centimetres. In question 21, I'm given a table showing the language studied, either German, French or Spanish, by either males or females. I'm told that a sample of size 50 is taken out of the 258 students, and I'm asked to work out how many of the male students studying Spanish would be in the sample. So the male student studying Spanish is here. So my sample size is 50 out of the original amount of 258, and I need to know, with that proportion, how many would be left from the 26. So I need to do 50 over 258 times by 26. So I'm going to do 50 divided by 258, and I'm going to put that in brackets. That will make sure it does this bit first, and then I'm going to multiply that by 26, and I get 5.03875969. Now obviously I couldn't have that exact amount of students, so I'm going to have to round that, and rounding that to the nearest whole number is going to be that 5 students would study Spanish. In part B, I'm asked to work out the number of female students in the sample. So again, I've got the same proportion, 50 is my sample size out of my population of 258, and I'm multiplying that by the number of female students in the sample. So the number of female students will be here if I add up 25, 48 and 62. So I need to do 25, add 48, add 62 and multiply that by this proportion. Now I can do this first if I want, or I can do it all on the calculator at once. So I'm going to do it individually. So 25 add 48 add 62 is 135. So I'm going to do 135 multiplied by this here. So again, opening the brackets, 50 divided by 258 gives you the proportion I want, and it's over 135, so I'm going to multiply by 135, which gives me 26.16. 907. And again, I can't have this exact amount of students, so I'm going to round that to the nearest whole number, which would be 26 students. On question 22, I'm asked to prove that this expression here is a multiple of 4 for all positive integer values of n. So the first thing I'm going to do is I'm going to try and simplify this expression slightly. So 3n plus 1, 3n plus 1, because I'm squaring it, so that's going to give me 9n squared plus 3n plus another 3n plus 1. I need to take away from that 3n minus 1 squared. So 3n minus 1, 3n minus 1, and again I'm squaring them. So 3n times 3n is 9n squared, take away 3n, take away 3n here, and add 1 here. So for this bracket I've got 9n squared plus 6n plus 1, and for this one I've got 9n squared minus 6n plus 1. And the second one is being subtracted from the first one. So 9n squared take away 9n squared would be 0, so those will disappear. 6n take away negative 6n is going to be 12n, and 1 take away add 1 is going to end up as 0 as well. So I'm just left with this single term, which is 12n. Now 12n can be written as 4 lots of 3n. So I'm doing 4 times by some other number, and therefore that answer must be in the 4 times table. For example, if I used n equals 1, I would be doing 4 times by 3 lots of 1, and that's going to be 4 times by 3, and therefore it's in the 4 times table because of this number here. Doesn't matter what I put in here, I'm always going to have 4 times by something, and it's going to be in the 4 times table. So I just need to write a comment somewhere along those lines showing that this is always going to be a multiple of 4 times tables. On question 23, I'm given a triangle OAB, and I'm told that O to A is A, and that's going in that direction, and that O to B is B, in that direction. I'm asked to find the vector A to B, so I'm going from A to B. Now I can't go there directly because I don't know anything about this line, but I can go in this direction. So I'm going to go from A to O. So A to B would be A to O plus O to B. So A to O is the opposite of A, so that's going to be minus A, and O to B is going to be still just B, so I'm adding on B. So I can write that as either minus A plus B, or I can write it as B minus A. Both of those would be fine and mean the same thing. In part B, I'm told that P, which I can see here, is on AB, such that A to P, this distance here, is worth 3, and P to B is 2. Well, this is 2. Now that means that this here, this distance A to P, is 3/5 of the line, and this distance here is 2/5 of the line. So A to P is 3/5 of A to B. Now I can use that information to work out O to P. So O to P would be O to A, and then I'm going to add on A to P. So I'm splitting this journey up into these two separate sections, O to A, and then A to P. Okay, O to A is reasonably straightforward, I've already been given that, is A, and I'm adding on A to P. Well, A to P I don't know, but I do know that it's 3/5 of the distance A to B, and I do know what A to B is. So that would be 3/5 of A to B. Okay, so I'm still doing A, and I'm adding on 3/5 of A to B, which I know is B minus A. So I'm going to get A plus 3/5 B minus 3/5 A. And if I tidy that up, well, I've got A minus 3/5 A. That is going to be 2/5 of A, and I'm adding on 3/5 of B. Now I'm asked to show that it's equal to this, so what I'm going to have to do is divide both of them by a fifth and get that O to P is 2A, because 2 times by 1/5 will be 2/5, added on to 3B, because 3 times by 1/5 will be 3/5. In question 24, I'm given an equilateral triangle, so I know that all of the angles are 60. Mark that one to start with, that's 60, and that's going to be 60. And the sides are all 6 centimeters. I'm told that P is the midpoint of A to B. So I've got this point here, P, that is the midpoint, and similarly I'm told that Q is the midpoint of AC here, and that APQ is a sector of the circle, and I can see APQ is a sector of the circle, centre A. And I'm asked to calculate the area of the shaded region. So the first thing I need to know is the area of the triangle, and I can work out the area of the triangle using the formula half AB sine C. So a half, and now I need to label the sides. So I'm going to work out the area of the triangle, and I'm going to use the angle C, which will make my life a little bit easier. So that would be, this side would be C, this would be the side A as it's opposite the angle A, and this would be the side B because it's opposite the side B. So a half AB, so A is 6 and B is 6, a half times 6 times 6 times by the sine of C, which would be sine 60. And I can work that out on my calculator again. I'm going to make sure that I'm in degrees by pressing this button. And I'm going to do half 0.5 times by 6 times by 6 times by sine 60. And I get that the area of the triangle is 15.5884577. And it's important that I write that full number down. Okay, now I need to know the area of the sector of the circle. So I'm going to work out the area of the sector. And to do that I need to know what fraction of the circle it is. Well, it's 60 degrees out of the full circle of 360 degrees. And then I just need to find the area of the full circle. Well, that will be pi times by the radius squared. And the radius of this circle is not 6, that's from here to here. It would be this distance here, which is 3 centimeters. So pi times by 3 squared. Again, work that out on my calculator, and I'm going to put a pair of brackets around this. So I'm going to do in brackets 60 divided by 360 times by pi times by 3 squared. And that's going to be 4.712 and a few more numbers. Okay, so I've now got the area of the sector, this bit, and the area of the full triangle. So to work out this shaded area, I'm going to do the area of the triangle, take away the area of the sector. So this number, take away this number, and 15.588, a few more numbers, take away 4.712 and a few more numbers. And again on your exam, remember to write out those numbers in full. So 15.5884577, take away 4.71238898. And I get the answer is 10.87606.829. Now I am asked in the question to round this to 3 significant figures. So the first significant figure is the 1, the second one is the 0, it counts because it's after another non-zero number. So the third significant figure is the 8. So I look at the 7, which is 5 or more, so we need to add 1 to this 8. So my answer is going to be 10.9 centimeters squared, and the units are already there. On question 25, I'm asked to simplify fully this expression here, which has got a quadratic on the top and one on the bottom. So I'm going to need to factorize both the top and the bottom. So factorizing the top expression, some people can do this in inspection, some people need to sit and go through a method. I'm going to get that I've got x and x at the start. These would multiply to give me x squared, and I need two numbers that multiply together to give me 15 and that add together to give me minus 8. So I can see that that would be minus 5 and minus 3. And if we want to check that, you can always, it's worth doing, multiply out those brackets. So that would be x squared minus 3x minus 5x plus 15. And that's going to get me x squared plus 15 minus 8x. That is going to be over this bottom bit factorized. So I'm going to have to factorize the bottom bit. So I'm definitely going to need 2x. And then multiply by x to get me 2x squared. And now I need a couple of numbers that multiply to give me minus 15, but then when combined with this 2x and x will give me minus 7x. So usual method for this is we call a is the first number, which is 2, b is negative 7, and c is negative 15. And we do a times by c, which will give me negative 30. And I'm still interested in b, which is negative 7. So now I need two numbers that multiply to give me negative 30 and add together to give me 7. So looking at that, it's going to be negative 10 and positive 3. They'll multiply to give me negative 30, and they will go together to give me negative 7. So what I've got to do now is take that information and work out what my brackets would be. So there are a couple of ways of doing this. Some people do it by writing 2x squared minus 10x plus 3x minus 15, and then splitting that expression in half and factorising both sides here. So I could have 2x here, and then I would have x minus 5. Take this bracket and repeat it over here, x minus 5, and find out what times by x gives me plus 3x, which would be plus 3, and that would give me both my brackets of 2x plus 3 and the x minus 5 that's repeated on both sides. There are other ways of doing it. Use whichever one works for you. I've now got this expression with x minus 5 on the top and on the bottom, so I can cancel that and end up with my final answer of x minus 3 over 2x plus 3. It doesn't matter how you factorise them as long as you can get to those two expressions. If you're not sure, once you factorise the bottom, by all means multiply that out and see whether it works. 2x plus 3 and x minus 5. Do you get what we're after? We get 2x squared, we certainly get minus 15, we're getting take away 10x here, and we're getting add 3x here, which is what we want. Put these together and I get minus 7x. On question 26, I'm told that Phil has 20 sweets in a bag, and I'm told that 5 of them are orange, so 5 out of 20 are orange. 7 of them are red, so 7 out of 20 are red, and 8 of them are yellow, so 8 out of 20 are yellow. I'm then told that he takes at random 2 sweets from the bag. So that's similar to taking 1 sweet and then another sweet directly after. And I'm told to work out the probability that they will not be the same colour. Now to do this a couple of ways, I'm going to do it with a tree diagram. So we're going to take with the first pick here. I suspect it's going to run out of a bit of space, which is that he could take an orange sweet, he could take a red sweet, and he could take a yellow sweet. And we'll put all the probabilities associated there. So 5 over 20, 7 over 20 for red, and 8 over 20 for yellow. Okay, so then he's going to choose again, second pick. So assuming he took an orange first time around, I'm now going to go, okay, he could second time around take an orange, he could take a red, or he could take a yellow. Now if he's taken an orange out first time around, there's only going to be 19 sweets left in the bag for all of these probabilities. Now if it was an orange that he took out, there's no longer 5, there is just 4. The number of reds will stay the same as 7, and the number of yellows will stay the same at 8. So that's assuming he took an orange first off. Now, next bit will be to repeat that process, orange, red, and yellow, for assuming he took a red out first time around. So again, there's still only 19 sweets in the bag, because we've taken one out. And if he took a red out first time around, there's still 5 orange left in there. There is, however, only 6 reds, because one of them is gone, and there would still be 8 yellows. And the third and final one is assuming he took a yellow first time around. So orange, red, yellow. And again, we've taken a sweet out, so we're down to 19. We took an orange out here, a red out here, but here we've taken a yellow out. So all of the numbers for orange would stay the same as 5. For red, it stays 7, but the yellow is going to go down from 8 to 7. So we've now got our completed tree diagram. We're going to write the outcomes on first. So this is orange and then an orange. Assume we went along both of those branches there. That's all I'm doing. I'm saying let's assume we did that. That gets me orange and orange. And carrying that on, I've got orange and then red. I'm working my way down, orange and yellow, red and orange, red and red, red and yellow, yellow and orange, yellow and red, and yellow and yellow. Now the question wants me to work out the probability that they will not be the same colour. So the ones that are not the same colour are there, 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 and there. So I need to know all of those probabilities and add them all up. Now to work out individual probabilities, I need to multiply as I go along the branches. So for this one, I've got 5 over 20 times by 7 over 19. And that's these probabilities here associated with going orange and then red. And then for the next one, I've still got 5 over 20, and now it's times by 8 over 19. Now for this one, I've got 7 over 20 going along this one, and then 5 over 19. And then 7 over 20, and 8 over 19. And finally, I've got 8 over 20, and 5 over 19, and 8 over 20, and 7 over 19. Now, if I work out all these probabilities out, I'll then be able to add them up and work out my final probability. So times the top and times the bottom. So 5 times 7 is 35. 20 times by 19 is 380, and that's going to be repeated all the way down. So this is going to be 40 over 380, 35 over 380, 56 over 380, 40 over 380, 56 over 380. Now all I've got to do is add all of these probabilities. So when I'm adding fractions, I can simply add the denominators being the same. I can simply add the numerators. So I'm doing 35, add 40, add 35, and working my way down, add 56, add 40, add 56. So I've added those 6 numbers and I've got 262. So my final answer is 262 out of 380. Now, there is a slightly quicker way of doing it. I just wanted to do this for illustration purposes. Is you'll notice that the ones I haven't used, orange and orange, and red, and yellow, I could have worked out those 3 probabilities and done 1 take away those amounts. So if I'd done 1 take away the probabilities for orange and orange, red, and yellow, I would have got to this value as well, just slightly quicker. That concludes the exam paper.